So this is going to be naming and providing the chemical formula for polyatomic structures. The three letters that have previous, what three letters have previous compounds ended with? So far we have learned that compounds end with I, D, E. Okay? Okay. So I want to illustrate a point here. Okay? NH is going to be drawn NH. That's not a molecule, I'm just saying. NH4, which is actually NH4 plus, is going to be an N with, it's going to be 4 N's, or 1 N, and 4 H's attached. Follow what you see, not what I say. Alright, NH4 is an N with 4 H's. It actually has a plus on it because it has more hydrogen, more protons than it has electrons. And then NH4 is going to look something like 4 NH bonds. Okay? So notice that there's a difference here, okay, between these three things, right? And these three things are very important to see the difference. So a polyatomic ion, let me look at what my definition was the last time I wrote these notes, are covalently bonded atoms, right, molecules, that have an ionic charge, right? So NH4, it has a plus charge, so it's going to work as an ion. Okay? How do you know you have a polyatomic ion? If you've got a chemical formula, in this class, if you go to college chemistry and you repeat this, then your professors and classmates are going to laugh at you and think you're crazy. So don't say this in college, but for now, chemical formulas that have more than 2 atoms are polyatomic. Okay? In naming, except hydroxide, which is OH negative, if it ends anything but so if it ends with IDE, it's most likely going to be on your periodic table. If it ends with anything else, it's probably a polyatomic, and you will find it here. Okay? So again, they end with 8s. Cyanide is also another one that ends with IDE. But hydromium, nitrate, nitrite, right? They end with 8s and ites a lot. Okay? So let's go name to chemical formula first. So ammonium sulfide. What you want to do is you want to make sure that you protect your polyatomic. So ammonium, I look at my periodic table, okay, and I find ammonium here. It's going to be NH4, right? There's no element. You can search for ammonium on your periodic table. It's going to be a waste of time. It doesn't exist, okay? This exists, okay. So ammonium, I'm going to put the NH4 in a parentheses because this applies to everything. And then sulfide, because it ends with IDE, I know that I find sulfur on the periodic table. So S, sulfur is on group 16, so it's going to be -2. Now that I have oxidation numbers, because I've been following the rules and knowing what to do, I know to just cross. Okay? So then my answer is going to be NH4 parentheses 2S. If you don't put that parentheses in, you're saying NH42S, and you're just wrong. You're just very, very wrong. This means 2 NH4 ions. Okay, if I need to draw it, right, it is 2 NH4s, right? Giving their electrons to sulfur to get that those pluses, right? So NH4, they're giving electrons to the S to get a -2. Okay. Let me go to the next page. All right. So here's an example. Here are some examples. So for copper 2 chromate, you're going to notice that it has a Roman numeral. So it's going to be copper. That 2 doesn't go on the bottom as a subscript. If you do it, you're wrong. And then you look up chromate because it doesn't end with IDE. All right, chromate. I'm going to look here. Chromate is here. It's CrO4 -2. CrO4 -2. So I'm going to write CrO4. And then -2. All right. In this situation, 2 minus 2 is 0, so I can just write CrO4. If you are really bad at this, just leave the parentheses. Okay, but otherwise, leave it alone. Okay? All right, let's go to the next one. Magnesium, I know, has a +2 charge. Magnesium is going to be Mg + 2. Chloride ends with IDE, and it's not hydroxide or cyanide. So I know that chloride is chlorine as an ion, and it has a -1 charge, right? Again, doing what we do. We're going to cross it down. I guess I didn't need to draw my cross arrows in the last one, but that's okay. MgCl2. You don't say that you have one Ms-Akimoto. You just have Ms-Akimoto. There aren't any other ones, right? You don't have to say one if there's only one. All right, let's do one more final example, right? So aluminum is in group 13, so it's going to be +3. Sulfate, I look here, and it's SO4 -2. You want to be careful because sulfite exists. You don't want to mess that up. It's going to be SO4 -2. All right, now that I've got my parentheses and my oxidation numbers, I'm going to cross down. It's going to be Al2 SO4, put that in parentheses, 3. Because otherwise you are saying Al SO43. And that's just crazy. No. Okay? Hey, let's do naming real quick. Alright. So, I seem to have lost my sheet. How do I do that? I don't know. Alright. Here we go. For naming, you're going to follow all the rules that have already existed, right? You write the polyatomic ions by finding the ions on the reference sheet here or here. All ionic rules apply, including the Roman numerals of stock elements. Do not write Roman numerals if the cation is in group 1, 2, or is aluminum. All right, so cobalt is not a alkali metal or an alkaline earth metal. So cobalt, I know, is a transition metal. Right, I need an oxidation number. All right, so to get the oxidation numbers, I have to bring up my subscripts. Notice SO4, right? A lot of people will be tempted to bring that 4 up. But you can't just bring up that 4 because it's part of the identity, right? My name is not Ms. Akimoto. You can't just say Akimo, right? My name is Akimoto. You can't just drop things, right? So if I cross up subscripts, it's going to be CO plus 1, SO4 minus 1. Okay, this is a complicated one. Because if I look at my polyatomic sheets, right, cobalt, first of all, doesn't have a cobalt 1, and SO4 has a charge of -2. So that means I need to multiply this by 2, which means I need to multiply this by 2. So it's going to be cobalt plus 2, SO4 minus 2. Okay, because then we're still balancing out my stuff. All right, so that is the actual oxidation number of SO4. So my name is going to be cobalt, parentheses 2, sulfate. All right, let's go look at a couple more examples. For lithium, Li, MnO4, Li is an alkali metal. It's in group 1. So I don't actually need to write oxidation number. So I can just write the name as is. It's going to be lithium. And then MnO4 is going to be right here. Right here. Okay? It's going to be permanganate. All right, versus iron is a transition metal. It's not in group 1, 2, or aluminum. So I'm going to have to start crossing up my oxidation numbers. I'm going to cross up Fe's, minus 1. Cross up that 3 on the outside of the parentheses. It's going to be Fe plus 3 HCO3 -1. If I look, HCO3 has a charge of -1, and iron can have an oxidation of +3, so that has to be right. So it's going to be iron 3 hydrogen carbonate. It's a long word. I don't like that one that much, but that's okay. All right, I'm going to do one more just to make sure that we are sure what we're doing. Okay, so ClO4, again, you can't just drop parts of people's names. You got to keep the whole thing. Right, I'm going to cross up these ones. So it's going to be Cu plus 1, ClO4 minus 1. I look at my periodic table, and I see that ClO4 is perchlorate, and it does have a -1. Copper can have an oxidation number of +1. So it's going to be copper 1 perchlorate. All right. Hope that that helped. If you have any questions, please ask your chemistry teacher, whether it be me, Ms. Heverdays, Ms. Logan, or Ms. Smalling. Thank you so much. Have a good day.